Hello, welcome to another class with me. My name is Ming. Today we're going to look at this learning target. That is, I'm able to find the volume of a solid from revolving about the x-axis. That is, you have a function and you make it revolve around the x-axis, and you need to find the volume that it is obtained from this particular solid out of the revolution. So we're going to start by looking at this simple example. The function here is just y equal to square root of x, and it's between 1 to 4, that is this particular region, and we rotate it around the x-axis. What do we get? So, well, if we rotate it around the x-axis, each of these vertical line become a circle, and in fact, if they have thickness, this become a cylinder. So in this particular cylinder, right, like this, the radius, because this is the x-axis, the radius is given from the x-axis up to the function that is the radius. So in this case, it's just the value y at this particular point x. The thickness in this case is h, and the thickness is of this slice, or you can think of it as the cylinder, is going to be delta x. So if we want to find the volume of this particular solid like this, which look like it look like a ball, but this ball is solid. It is not hollow, right? And well, first of all, we can think of it. This is the volume of a slice. You can think of it this as part of a cucumber, for example. All right, and each slice of this cucumber is actually the volume of a cylinder. So pi r square h, and y r itself is y, so become y square, and h is delta x, so it's that. And then you can think about this as slicing cucumber. I slice all the cucumber, right? Many pieces, maybe like 20 pieces. And then I glue all the all these slices of cucumber back together. In order to do that, and allowing the delta x to go to 0, I will have this, right? And if you allow the delta x to go to 0, then the volume is going to be simply 1 to 4, right? Pi r square, in this case, is y square delta x. The delta x become dx. The delta x becomes dx. So this become integration, all right, with y squared. So let's see how this can be used. So we now try to find the volume. So volume in this case is the pi. Because pi is a constant, I can take it outside of the integration sign from 1 to 4 of square root of x, everything square dx. So that become pi. Integration from 1 to 4 of x dx. So if I do this in integration, so this become x squared over 2 from 1 to 4 with a pi outside. So the answer in this case is pi, big bracket, 16 over 2 minus 1 over 2. So the final answer is 15 pi over 2. Now, if this is a paper 2, then this is what I would suggest you to do. You will still set up the equation, set up this problem, pi times 1 over 4, and then in this case, square root of x, everything square dx, and then you will get pi over here, and then from 1 to 4, the integration sign of x dx, and now you use your GDC. For example, using GDC at this stage means doing this. That is, you put in, you go to menu, make sure you go to calculus. Sorry, too fast. So cancel. I go to menu, go to calculus, and then numerical integral, and then I put in here 1, and then on top I put in 4, and then over here I put in a bracket, and then I put in pi. Where's my pi? Over here, pi, and then bracket again. All right, this is going to be just x, and then bracket, and then dx. All right. Oh, there are two. So dx, and then press enter. So this is 23.5619. So this is roughly 23.6. 23.5619, 23.6 unit cube to 3SF. Right. So if you go do 15 pi over 2, you get similar answer. All right. Thank you. And